Hello, thank you so much for joining us today for our Know Your Malt webinar. This is a part of a larger webinar series that we're really excited to bring you all about grains and specifically for industry professionals. My name is Cassandra Malice. I am a program manager at Craft. And I'm very happy to introduce you today to our panelists and to our moderator. Some things I just want to mention quickly is that we are recording this webinar. And so you can find this webinar after today if you want to go back and reference it, or if you're not able to view it today, it'll be on our Craft YouTube page. Additionally, the past webinars we've done so far, which include a branding local grains, marketing local grains, and a brewing local, are all recorded and available for you to view. And next week we have the last in this series, which is a recipe development webinar, specifically with using local grains. So tune in on Monday at noon for that as well. We will have the chat function and the Q&A available for you all, for attendees to participate in this discussion. So feel free to put any comments or questions in there, and we will make sure that Oana and Brendan address them. And one final thing is that at Craft, we recently launched what we're calling the Commonwealth Grains Community, which is a community of grains professionals in Western Pennsylvania. I will put the link to join that in the chat if you're interested. It's a networking and a place to learn about educational opportunities involving local grains in the region. And without further ado, I will let Oana and Brendan and Christina all introduce themselves. Thanks so much for joining.
You guys can go ahead first.
I was going to say, ladies first. We're
Go ahead, Christina.
Okay. Hi, everyone. My name is Christina. I am a master's student currently at Chatham University with my thesis focusing in regional grains within southwestern Pennsylvania, and I'll be defending at the end of August. But today I'm just here to help moderate this malting workshop, and we have Oana and Brendan here who are going to tell us about CNC Malt.
Okay. Go ahead.
Thank you. Yeah, my name's Brendan Carroll. My wife, Oana
Carroll. Hi.
And so we're the founders of CNC Malt Company. It stands for Custom and Craft Malting. We're located in Fenelton, Pennsylvania, in between Butler and Katanning in an old elementary school. And we have a slideshow put together to kind of go through all what we have, and there's a video as well. It's too bad that you can't all come out to the malt house and see what we have going. And I think as a picture speaks 1,000 words, videos probably speak a million, because that's a bunch of pictures, right? So I guess we'll start by going through the agenda here, so you know what you're all in for. So we've kind of gone through and introduced ourselves. The malting barley is the key to malt. So if you have good malting barley, you're probably going to have good malt. You're going to have good beer. So we'll spend a bit of time talking about malting barley, then we'll have a quick overview of the malting process, and then show it to you in more detail in the video. And after that, we'll move on with different styles of malt that we could produce. And from there, we'll go into the malt analysis and we'll spend some time on that. So on the brewing end, when you get a COA or something, if you're not familiar with what all the parameters are telling you, hopefully that'll shed a little more light on that. And so then we'll go to the applications of what malt could be used for, and wrap up with some questions. We'll try and leave a bit of time there for questions. So if you have any, I don't know if they pop up on the chat or not. This is my second Zoom meeting ever, so that's probably unique to this world. So if they do pop up,
I'll help you with questions and everything, Brendan, so don't worry.
Okay, well, thank you. So yeah, as we mentioned, the map shows kind of where we're at between Butler and Katanning on 422. We purchased an old elementary school, and it's really a very well suited to malting, with a few exceptions. You know, we don't really need chalkboards and things like that, but the concrete slab works great for floor malting. So we have 30,000 square foot that gives us quite a few floors to work with and allows us to expand our production as we grow. So as we said earlier, barley is really the key to what we do. It's the most common grain we work with. It accounts for most everything we do. So we'll probably talk a lot about barley. So there's the key to getting good malting barley is starting with the right variety. So this area is closer in climate to Europe. So we go towards European varieties versus the Western varieties. So some of the varieties that we really like are Calypso, Violetta, TP Odyssey. That's some of what we're working with now. We've done some whip malt in the past, but it's really not possible to get seed anymore. With the growing malting barley, you have, so the key is having that proper barley that's going to work well in our area. And so one of the things we have with the moist climate is fusarium. So fusarium leads to dawn, which leads to beer gushing, which we'll show in a moment. So you have to spray to control that. So there's 2 spray applications. And if you miss one and the moisture's up, you're just not going to make a crop. We saw that with one farm this year. They tried getting away with 1 spray application and didn't make a crop. The harvest window, once the grain dries down and then it is ripe, if it starts to pick up moisture, then you have issues, especially if you have a variety that's not proper for this area. So we work very closely with our farms. We're in constant communication about what we're going to plant when we're planting next, how the applications are going, how many acres to grow, what varieties, where to get seed. And so we work with farms in Butler County, Westmoreland County, up in Mercer County, a little bit in Ohio, throughout the state as well. But those are the main areas we work with. So the variety difference, if you heard 2-row and 6-row, there's a little corner picture there. A lot of people ask about that because that's what they know about barley. So 2-row grows up and it looks like a V as it grows. It comes straight up. 6-row, it looks like a club. It kind of spirals around the stem. So that's the difference between the two. And 2-row is generally better for brewing, but there's some excellent 6-rows. A lot of brewers are hesitant to try 6-row, so we generally don't grow them. We have some, but not a lot. Now, so as we said in the previous slide, the things that we really have to watch out for are the fusarium, which causes dawn, and pre-sprout issues. So if you have the wrong variety, you could have pre-sprout. And it's important too to choose a barley variety that's proper for malting, not for feed. So with malting varieties, you'll have higher, you'll have a mid-range protein. With feed varieties, you end up with a higher protein. So when the barley comes in as well, jumping kind of around the slide here, we have to get the moisture just right. So if we harvest early, because we know the grains are starting to ripen and the moisture event's coming, then we have to dry the grain down for storage. So we can harvest 18, maybe even up to 20%, but then everything becomes very critical. You have to clean it very rapidly, get it into a dryer, dry it down with low temperature, and and it takes a lot of energy and time to do. So you have to be set up and prepared to handle all that. Ideally, if it's dry at harvest, you just let the nature run its course and it'll dry down 13, 11%, 9% even. You start getting below 9%, you run a risk of losing germination. So if we could harvest in that 9 to 13% window and not have to worry about drying, that's perfect. And we're very blessed this year. It all kind of worked out like that. Other years it won't, so we're prepared to handle that in the future. The pictures there, the top, I guess it's middle left, shows what pre-sprout is. So that's a very dramatic picture of Presprout where the grain ripened, it rained, and then it started actually growing in the head. So you can see the growth start. That middle bottom picture is a picture of gushing. So if you ever opened a beer and it just all erupts and goes out, that's what gushing is. I've seen videos of actually bright tanks emptying, or fermentation tanks just emptying. So you see a 100-barrel tank just gush out. That's it's a sight to see, but it's not something you want to see. So good, healthy barley looks kind of like the picture on the right. There's no pink kernels in there. That's not yet ripe, but it's developing very well. You're past the stage where fusarium is really an issue. That's what good barley looks like. So we'll talk a little more about RVA when we get into malt analysis, maybe on the next slide. So the picture here on the next slide is kind of how we take in grain. So we could receive a dump load, a belly hopper anyway. The grain comes, super sacks. We get it in the first bin's the receiving bin. We run it out of there through cleaning. As we're cleaning it, we'll grab samples and then we'll test it. And then we send it to storage. I think so. We'll hit a little on RVA. Above that testing there, you see that's the last number that's not cut off. That RVA, if the pre-sprout's not visible, it still is possible that it's there. So what an RVA is essentially we test the viscosity of a porridge of malt water at 150 degrees. If any alpha amylase is present, it causes that viscosity to crash. So RVA is really a viscosity number. So high is good, low is bad. So for the malting process, when it actually becomes something that's unique to us, there's 3 to 4 main steps. So the first step is steeping. We have to get it from that 11 to 13% in storage back up to about 44% moisture. So we do that by putting it in water. So as we're doing that, it bubbles out all the junk and we'll get that moisture up. And we'll talk more about all this in the video. So I think we'll just look at the pictures there. After steeping, then we go to germination. That's where it grows. That takes about 4 days. And that's where all the magic really happens. Steeping's critical. Germination's kind of when the barley does the work. Then kilning is where we do the work to lock in everything at its final spot. So when we're kilning, we're drying it and we're preserving it at just the right spot for brewers to use. And after that, we have to knock off the roots and get rid of all the broken kernels and grain that it wasn't just quite right. And so then we clean it again, and that's the final step before we bag it and send it off. So I think at this point, we could go ahead and roll the tape and see what the malt house looks like.
Awesome. I will get that going for us, and just let me know. I'm going to stop your screen share.
Perfect.
And start this one. And let me know if it all works out.
Vince Mangini with Food 21, back with another installment of the Barley Report. And if you recall, earlier this year, we got our seed into the ground and we followed their progress through spring and summer and the actual harvesting. And now we're at the point where we're going to convert those grains into malt. And to do that, you need a malt house. And luckily in Western Pennsylvania, we have CNC Malt, located in a little town of Fenelton, just outside of Butler, PA. And Brendan, the owner, who is the maltster here too, head maltster, he's going to take us through the process of what it takes to convert these kernels into malt. And hopefully what we can get from this is an appreciation of the process. It is scientific in nature, it's repeatable, but there is a sense of a little bit of artistry and craftsmanship involved in this process, and hopefully Brendan can educate us on that, and we can get a little appreciation of what's involved.
So barley comes to us in many forms, from 55-pound bags up to tractor trailer loads. So when we're receiving barley by the tractor trailer load, we need to get that unloaded rapidly and into something that'll hold a tractor trailer load plus worth of barley. So we use a portable auger, which has been ported elsewhere, to load it into our receiving bin, which is being modified at the moment. After being received, then we clean the barley, and upon cleaning it has to be dried to a storable condition. So the back bin behind us is the drying and storage bin, and the fuel source we use for drying the barley is wood pellets, our wood pellets. And so there's a biomass furnace in the back that goes into a manifold that mixes the air to just the right temperature so we keep the barley alive.
And that's part of it, you know, the malting is science to it. It's been done for thousands of years, but the artistry part of it is how to have the appropriate amount of heat and the time of the heat. The process is steeping, and that's where water is added to the kernels to start the germination process. And we're standing in front of Brendan's big steep tank.
Yeah, so this is probably the most critical part of the process and the first step in actual malting. So everything else could be any other industry. Malting is where we're taking grain and getting it to grow and then drying it out. So the adding moisture to the grain takes about 2 days, and it's not done all at once. You have to do it through several steps so you don't drown the grain. And during that process, the same, we have to keep air moving so we don't overheat the grain as well. So we're going from roughly 11-12% in storage up to about 44% moisture. So it's getting that barley to take up that water, and there's different fans and blowers.
So what happens in the tank?
So in the tank, when it first goes underwater, we have all these hoses going around to little induction nozzles that stir up the barley. So that helps, while we cleaned it out there, there's still straw and debris and stuff that isn't of interest to the brewer or distiller. So when we stir it all up, it removes a lot of that dust, and we could overflow the straw off the top. So it's really kind of a cleaning process. So then after being underwater for about 8 to 12 hours on the first steep, the water's drained off and the barley's retained. And I don't know if you can see the cone through this man door there, but that's the purpose of that. Then we have to draw air through it. So there's a duct in the back that sucks air through to keep it cool and keep it oxygenated. And then you repeat the process.
How many times?
About 2 to 3.
Not only do we get it to take up moisture while it's underwater, but we get to float out the little...
I can see we have a little bit of the sprouts starting.
Yep. But the dead kernels and stuff that aren't going to contribute, we could remove at this point as well. So water's good for cleaning and separation.
We grew.
That it is, the Odyssey 2-row spring barley. This is fresh out of steep, and so what you have here, you can see those little white parts there, the emerging rootlets. That's about a perfect steep outlook, and if you smell it, it has kind of a spring rain kind of fresh smell to it, so that's very good.
And this is more of our stuff too, a little bit earlier?
Correct. This has been out for about 2 days now, so you can see those roots have gotten quite a bit larger, and probably about another 12 to 24 hours this will go to the kiln. And you could test the how well it's progressing by kind of peeling back. The side opposite the roots is where the little plant grows out, and that's called the acuspire. And you can see he's about full length there. So that's indicating very good modification. So I'm thinking it'll be closer to this evening. If they're all uniform, this will be going to the kiln. And so far your malt's malted out very uniformly. So
That's great.
well,
Oh, wow.
yeah.
This is pretty impressive.
Yep. So this is more Westmoreland County barley. This is a 6-row variety called Thoroughbred. That
okay.
If you remember when we were down looking at your fields, the Heinekels had some growing right next door to you there, and they were saving theirs for feed, but luckily Fred Swazak had some more from Lone Maple Farms that he was willing to part with. So we purchased all he had, and this is about half of it. So we have about 3 tons here in this room growing, and I'm very happy with the way it's coming out, very uniform.
Now, will this have a different flavor profile from ours?
It will. So the kernels are a little smaller. They're going to have a little higher nitrogen, a little more enzymatic activity, but the flavor profile, we have a beer in the back I think we could taste it in,
It's definitely unique. It's a this would be typical of American beers, all American beers, especially pre-Prohibition beers.
Oh.
So for someone looking to do a more historical type of ale or so, this would be the barley you would want to use.
Because we're actually talking about working with some of our stuff for the old Hannistown ale, and maybe this would be a good grain for it.
Interesting, yeah. Okay. Definitely be a candidate.
This is nice. The next part of the process is the drying. So we've had the barley on the floor, and it's started the process of growing basically. And so now we've got to get it to stop. And it brings over to the this is CNC's big kiln. And Brendan's going to talk to us a little bit more about what happens here, part of the magic.
All right, so it's almost kind of the reverse of where we came in, right? We had to dry it down, so that's the same, and then we're going to have to clean it up after this. So the purpose of drying, like Vince had kind of mentioned there, is to pause the process. So if we allowed the plant to keep growing, it would break down starches more, and there'd be less extract for brewers. So at this point, we have a lot of different paths we could take. If we want to maintain as much enzyme potential as possible, we're going to dry at very low temperatures, and that would be something distillers would probably be interested in. We could create a lot of different flavors by the temperatures that we hit and whether or not we recirculate moist air. So there's this becomes an artsy part as well. So we could really develop again, different styles of malt depending on what we do.
Basically, it's the flavor profile of the beer we're creating here. So the craft brewer is going to ask you or tell you what they kind of want, and then this is where you do the work and create that for them.
Correct. And on the nuts and bolts of it, there's a wedge wire floor here to allow the air up through. It's larger than you'd have in a mash tun. I think it's 68% open area or so. Large air plenum underneath.
So the hot air is down here.
Exactly. So all the air blows in, and to make sure we have even air distribution, you want to give it a lot of space so that it could come up through the grain. The grain bin will sit about this deep. We learned on our pilot system that sometimes you need a little bit of extra head space, so we have more space up above for distributing the barley evenly and making sure that we could fit in the full batch. So we could walk back to the furnace and look at that afterwards, but basically air's coming in just opposite us underneath, blowed up through, and then it exits out the window there to be exhausted to the outside.
Maybe this is a stupid question. Will the kernels fly around in here? Will they sit on the bed? Or?
No, so we are putting air through at a much higher velocity than we are out in the drying bin, but it's still not high enough to blow through this thick of a bed. Now, if we were to have a very thin bed, yes, you could have what's called like a volcano or something where it'll blow through, and then that's not good because you're not getting even air distribution. So it's a matter of keeping the air flow.
We're not quite done with the malt yet. The brewers need a clean product, and so all those little ends on the kernels need to be taken off, and that's what this machine does. And we have an example. Brendan's holding his hands, kind of a before and after product.
Yeah, so essentially this is green malt going into the kiln, and then this is malt that just came out of the debearder there. So all those little rootlets don't belong with the malt in the mash tun. So the machine spins around and beats them up, knocks off the roots, but they remain with everything. So then we take this outside and run it through a screener again to remove the roots and further clean up the malt.
And it's ready for bagging. We're head over to where we bag it. After everything's the malt has been cleaned, it comes over to the bagging facility, and basically it's a pretty easy process. We just put it in top.
Yep.
And it's weighed here, and it goes into the nice CNC bags, and then it's sealed shut.
Yes, sir, that's it. Pull the lever, and the scale weighs out about 55 pounds, whatever you dial her into.
Part of the process here at CNC too, it's quality control and quality assurance. So, and that starts when they receive the barley from the farmer. We've got to make sure that it's a good product. And so part of that is it's sent away to be tested up at Hartwick College. But part of the stuff that Brendan does here is also involved too. And,
All right, so probably the most important test we're running on grain coming in is germination. So it has to be able to grow and grow well. So right here we have 2 germination tests running of the same variety of barley, started on the same days, same year. One was grown up in Sandy Lake, one was grown right here in Clearfield. Now this is the 3rd day of the test. Every day we go through and pick out the seeds that grew and count them. And so we're looking for it to germinate 95% or better by day 3. So this will be the 3rd day here in about another hour. So we'll count these up. These should, for the test to be proper, be conducted at constant temperature and humidity. So that big stainless refrigerator looking thing in the back is the vessel in which we do that. It'll maintain temperature to 1/10 of a degree and humidity to percent. It's important too to have a good representative sample. So those brass sticks in the back are used for grabbing samples from either trucks or bags. You drive this through, open up the column. That way you get a representative sample throughout the column, close it, and then it pours out the end. And you would do that in several spots. And split the sample down using the rifle box there, that stainless box. Sends half of the sample one direction, half the other way, and you split this down 50-50 until you have everything to what you want. And that way you know you're sending as representative a sample as possible off to be tested, or that's what we're working with here.
and the quality control doesn't stop there too. It's got to be maintained all the way through the whole process. And so we have another machine over here.
Correct.
That when we were starting with the germination part of the malting, Brendan's going to talk about that as well.
Right. As we go through steep and germination, we're very concerned about moisture. So one of the most important machines to us in the lab is this moisture balance. So the way this works, there's a very sensitive little scale on there. We put a sample in there, and then there's a halogen lamp there that heats it up and bakes off the water. And the scale at the end of it tells you what the percentage of moisture is in that grain. So 40.87% is that barley at the end of steep, so it'll do one more immersion before we put it on the floor. Now, when we're all done with the process, we need to find out if we did a good job or not. And so a quantitative way to measure that is friability, and we could look at that machine now as well.
Great.
So this machine, once we're all done, we can find out if we did a good job or not and make improvements in subsequent batches. So the way it works, there's a sample in here ready to go, but it's loud, so we won't start it just yet. But there's a screen that spins around and around, and there's an arm in there that presses the malt against the screen here. So the malt that has been modified and is nice and friable will fall through. So you collect your good portion of your sample here and then discard it. And then the remaining bit in there is what we weigh and see what is left over. So if we're seeing whole grains, whole kernels, they may have been dead from the start of the process. That's why we run the germination test. If we see partial kernels, half kernels, that might have been something that didn't germinate long enough, and so it's left partial, or it was chopped up by an auger or something through all the movement of the grain from A to B to C. So that's at the end of it, if we're seeing those issues, we could go back and try and correct to make a better malt in the future.
So there's still part of the process. We can go back and rectify anything or try to help the malt along the way so we can get the optimum product.
Correct. I guess the final and most important is the sensory analysis, so more of a qualitative type method. So this was a method developed by Brees in partnership with New Belgium, and Lindsay Barr is one of the founders of that, and she's since left and started a company called Drought Lab, where they do a lot of sensory analysis on malt and hops and beer and things like that to make it more scientific and less subjective. So if you approach everything the same every time with a large enough population and panel, you could have more exact data on what a flavor is, which is something that we could argue over.
And I may have to step in here for a second. Your background. It might help us with this part right now.
So chemical engineering is what I went to school for, and so the chemistry part of it makes sense to me. So if I'm off on a tangent, then thank you for keeping me back on track. So what we've done here is we've made a dilute mini mash. So 150 degrees, 147 degrees or so, we hold the malt solution at for 15 minutes, then we filter it out so we don't have chunks, and then we have a nice solution that's very drinkable. So when we get to these teas, it just makes you feel good and you want to drink more. So we're looking we don't want to be overwhelmed by the sweetness, which is what you would get of tasting wort or, runoff from your mash tun. So what we're going to do here is taste these and see what they taste like. So right here we have a base malt. So this is what we call our American ale. It is commonly referred to as two-row. So all around good base malt. Here we have a crystal malt that's mixed 50-50 with the base malt. And the reason we have to do that, we have roasting as well. So in a roaster, you typically just crush your enzymes. There's no power left to convert the starches to sugars and get a real idea of what the flavor is. And besides, in a mash tun, you're not going to use 50% crystal anyway. So sometimes we knock it down to 15%, try and be more representative of what the brew will be. So we mix the base malt with the crystal to get a flavor. And for fun, we did just a straight crystal. So we look at color, we look at flavor, and then we try and map it out, see if there's any off flavors. Like grassy might be an example of an off flavor we could correct in the kiln. So if you're finding grassy flavors in a light base malt like a Pilsner, then maybe what you have to do is increase the temperature slightly to drive those flavors off.
So there's still a little work that can be done here with the malt.
Right,
and
and
change the flavor profile.
Correct.
So we're still. So we are wrapping up our tour, and we're in basically the warehouse, and we have the finished products here in CNC's newly designed bags. And Brendan can explain a little bit more about what's going on here and how we get out to the craft brewers.
Yeah, so fresh out of the kiln, we like to let our malt usually age for about 2 weeks before shipping out, and that helps with on the fermentation side and allows flavors to mellow out a bit. With a few exceptions, crystal malts are best used as fresh as possible. But
CNC's mission includes being eco-friendly. So what they've done too is they've included a biomass furnace. And so they can burn different types of malt, or even old malt, or even wood. So Brendan can talk a little bit about that real quick.
yeah, we have a unique position here. There's a lot of trees in Pennsylvania and a lot of telephone wires that need to be trimmed. So the wood chips that the crews remove, we have a home for them here, as we can burn them in the furnace for the heat source. Runs best on wood pellets, so we have wood pellets, and then as Vincent said, other combustible material like old barley works just as well too.
Okay, I think that's the end of our video. I was like, is your video working?
Yep.
There you are.
All right.
Great.
Should we get back to her?
Yeah. You guys have a few more slides to kind of wrap it up? Okay.
So on to the next slide there. And so the malt styles.
Yeah, you'll just need to share your screen, which should be at the bottom. There we go. Perfect.
Yeah. So yeah, there's base malts, specialty malts. There's different grains we could use. And we could do custom malts. Sometimes people want a special grain done up as a crystal or whatever it might be. So there's a couple different wheelhouses we play in, but for the vast majority of it's base malt, which you'd expect, that's what you use the most of. So if we break down our base malts, you could have Pilsner, American Ale, Pale Ale, Vienna Munichs. After Munichs, you're kind of, even using 100% Munich would really be pushing it. So calling the base malts kind of pushing it, might be more in a specialty bucket. But depending on how the barley protein is coming in will help us determine what we're going to do with the base malt. So lower protein malts are going to give you lighter colors because it'll be less fan produced, and they'll give you more extract and less soluble nitrogen overall. So you want the low protein malts for your Pilsner. When you start getting up into your American Ale, so like a classic 2-row, most people will call that, you could start going a little higher on the protein, take about a mid-range one. For pale ales and ales, Viennas, you want to get into the higher nitrogen one. Now, Viennas, you could create color different ways by recirculating some moist air. So that plays into some other reactions that we get into if there's interest. But that's the most base malts. On the specialty side, there's kind of 2 families. There's crystal malts. So I guess we have 3 crystal malts and roasted malts. So I'll break those 2 down first. So a crystal malt is when you take the green malt, instead of going to the kiln, you put it in a roaster and you seal it up, rotate it around at 150, and then essentially you're mashing inside the grain. So the grain itself is the mash tune. You create all your sugars. Then after that, you could raise the temperature, and depending on what temperatures you end at, you'll get different caramelization chains created and make darker crystal malts or caramel malts, whatever you prefer. And then the roasted malt is where you take the finished malt and go to the roaster with it. And that's where you get your biscuits, your victories, and chocolate malts. Smoked malts are smoking them, and they're more of interest to distillers. On the other grains we work with, there's wheat, oats, rye, and corn, and they're kind of in the order of usage there. Probably go to the next slide. All right. So the malt analysis. So we could talk on this here for, I guess, 6 minutes, my wife's telling me. So the first one, assortment, that's physical. That's what size kernels do you have, and that's going to be dictated by the incoming grain. We could clean that out physically to make that what we want, but it kind of is what it is. The moisture, that's something we're controlling by the time in the kiln. So we want to take down our moisture to a good level before we start raising the temperature to preserve enzymes. Protein, that's what God gives us in the grain coming in. So the protein is the protein. It will reduce some from the incoming barley to the outgoing malt because you lose some in the roots and stuff like that. Friability, that's a measure like we saw of how the grain crushes. Diastatic power is your overall enzyme potential, and alpha amylase is focused just on alpha. The extracts are what you expect to get in the grain, and they are based off the Congress mash is what we get back from the lab. So another extract method is the hot water extraction method, and that's more typical of what you would see in the malt house. So for extraction, fine and coarse, what you're doing is you're running a temperature profile like a continental step mash would be, where you start at about 120, raise your temperature up so you hold it at 45°C for 30 minutes, and you raise it up at a degree per minute, and then you Celsius and mash out at 170 for an hour. So that's the Congress mash. In the hot water extraction method, you hold it at a single temperature, 1 hour at 65°C. And so comparing those, you're going to get higher extract with the Congress. With the when we're comparing beta glucans and viscosity, they'd be higher with the hot water extract. Soluble protein is going to be higher with the Congress, as would be fan and color. So just to know that what you get in the COA is the Congress mash, because that is the gold standard. But the hot water extract would be more representative of what you would see in a single step infusion mash in your brew house, as most people brew in that manner. So on the left-hand side there, we kind of have the ranges of what's considered acceptable. And that really all depends on what you're doing. And again, this is kind of focused towards a base malt. So there's ranges because you may want something higher or lower. So if you look at higher, like fan, for example, if in an all malt brew, you might want around 150 milligrams per liter. And that the fan's going to help you with yeast nutrients, and it's going to help through, it should all be used up through fermentation. If you have too much fan, like if you get way above 200 and you're doing all malt, then you run the risks of having nutrients there for other critters that are going to produce off flavors, may not be desirable, and you may have some residual fan in your beer. So with that in consideration, it's better to start with somewhat lower protein barleys and have less fan, since I'd say 90% of what we're doing is for all malt brewers. And then we could have some specialty side stuff for the adjunct brewers who are using corn or flake corn, or for distillers who may do a lot of adjuncts and not necessarily have all malt. So the color, it depends what you're after, and that varies. And pH, you don't want it to be too much out of range. You won't get good extraction. So on the application side, we talked about most extensively about brewing with, and probably most extensively in that category with the base malts, as that's bulk of what we do. And of course, there's specialty malts that go into brewing, as well as oats and wheat and rye, things of that nature. Some of the other buckets that make up about 20 to 30% of what we do is distilling malts, and a teensy tiny bit for baking. So the distilling malts, you want somewhat the opposite of what a brewer wants. Now, this again all depends on the distiller. So if the typical classical distiller is going to want a high enzymatic power, they usually want high extract because they're trying to squeeze as much as they can out of the barley. They usually don't go hand in hand, so it's a hard one to meet. But if you have the high enzymatic power, the high protein, high fan, they're going to make up for extract with all their adjunct grains. So if they're doing like a bourbon or something where you have 50% or more corn and some all malted rye in there, then they're not too worried about extract. If they're doing a all malt Scotch whiskey type of deal, then they're going to want a high extract in their malt, so they become a little more like a brewer. So it depends. Distillers are fun. We like that a lot, and that's there's some great ones out there. So on the baking side, you kind of have two different camps you go in. So the diastatic malt would be your base grains up to about a Munich or so, and they contribute flavor, but they're also putting enzymes into your product. So with cookies, they really get soft as they sit, and that's kind of neat. You can leave them out and they just get softer and softer and softer, and that's like so my wife does most of the baking. She might have a bit more to say on that.
Well, I guess one note on the diastatic malt flour, obviously with all the active enzymes, it does affect taste. So you cannot really use it 100% as a malt flour. It isn't added into the baking industry. It definitely helps a lot with the crust and into the pizza doughs, but really it's just a small addition to your normal flour, like a very small percentage of like 2 to 5% of your mix.
Hey, Oana, it was a little hard to hear you because I think you're a little far from the microphone.
Oh, I'm sorry. Yeah, so what I wanted to say on the diastatic malt flour, it's really, you cannot use that 100% for baking. That is just an added to the whole mix in a very small percentage of like 2 to 5%. It really helps in the baking goods for the crust and in the pizza dough. And the problem is, since it has a lot of active enzyme, it will destroy the yeast if you use too much. Versus the rice, yes. So it would destroy the rice. Versus a non-diastatic malt flour, so you get more into the specialty malts like a crystal malt flour or a biscuit malt flour. It does add way more flavor. You could use more of that because most of the enzyme have been destroyed through the whole process. So with really, you're going to be using it more for flavor into your baking goods and cookies and stuff, versus the diastatic. It would really just to help with baking, but in just a very small percentage. And I think that was the last slide we had. We can open it up for questions.
Great. Yeah, I think we have a few participants. I'm not sure if you guys have any questions. You won't be able to use your microphone, but at the bottom of the Zoom, you'll see a Q&A bar and a chat bar. And so if you have any questions, you can go ahead and ask. But I have some myself. Yeah, I actually have some of your, I think it was last year, we had done in our previous grain box with you guys the non-diastatic malts, I think. And so we had some of that, and we actually used it for some focaccia that we made at the bread oven, and it tasted so good. It added that just like kind of like a caramel flavor to it. But what is it about like the enzymes that creates this softness with like the diastatic rather than like the non-diastatic? Like, what is it? What is it doing, like chemistry wise?
So depending on your baking temperature and time, you will denature some of the enzymes, but if they're still present, they're going to sit there and they're just going to do what they are meant to do, which is munch down on carbohydrates, and depending on which enzymes are present, maybe even some of the debranch the protein chains and stuff. So they're just sitting there. They're not very mobile, but so over time, it's more when everything's more liquid, like before it actually bakes, that's when it'll probably prevent some rise. But when it sits there, it could just, they're spread throughout, so they'll be munching and breaking stuff from carbohydrates to sugars. And
So would you say it's better in like a bread application, like with like a sourdough or something, or would you say it's better with
Correct.
like
It's mainly for bread and the pizza crust. And actually, if you ever notice, a lot of the pre-mixes, whenever you purchase a pre-mix and even for pancakes, and without throwing names out there, a lot of people do use a small percentage. So it's already pre-baked at the factory in some of those pre-mixes that people would get off the shelf to just use for baking.
So in general, enriched flour contains 3% malt flour.
Yeah, because I've even seen on like bread flour, sometimes you'll see malted barley flour added to the bread flour, and I always wondered like why is that in the bread flour? But I guess because more enzymes helping it kind of just get started on that. But cool.
Yeah, so the way you look at it, it helps you in a small quantity, and then it would actually hurt you if you pass that threshold, pretty much.
Yeah. And so, yeah, I heard in the video, Brendan, that you did chemical engineering. So do you do all this tests that you guys are showing us, all the equipment, do you do that all yourself, or do you send any of your barley to a lab to check for like Dawn and other things?
But both. Everything you saw in the lab is what I do myself, and then we'll send samples out. So the incoming barley, we catch a representative sample, and there's a couple little leaks here and there, so you put a bucket underneath and it drops a grain every 10 seconds, so it's perfect. And so we take that and we'll mail that off for the stuff that we can't test, so like protein, Don, and we'll have them also check the germination too, because it's with every test, there's a bit of variation in it. So germination in particular, our target's 95, but the what's the word for it? The uncertainty in the test is 10%. So if we get 95, it might be 85, it might be 100%. So the more times you run that test, the more certain you are that your number is correct. So it's good to
Yeah.
have another lab do it as well.
Yeah, for
And
sure.
then just as a matter of time, we'll do friability on the finished product and some of the flavor tests, but we'll send that out to get the extract and color and things of that nature.
Yeah.
It's all your
Yeah.
routine.
Yeah, because I've seen some of those, like there's like new like handheld monitors that you can use in the field for like protein, moisture, and a few other things. When I worked at a mill here in Texas, but we were working with like wheat and rye, a little bit different than barley, but and not for malting purposes.
Yeah,
But
same principle.
yeah, it was pretty similar. But yeah, I think it's always a struggle when I talk to people who are starting off is like realizing, you know, how much does it cost to get things tested at a lab and where do you have to send it and all these things. Are you guys working with like Penn State or a university or a certain organization?
We work with Hartwick College out of Oneonta, New York. They have a
Oh, because they did the brewing.
yeah, you're right. So
Yeah.
they've been really great to work with, and they offer a lot of good feedback. And so Aaron McLeod is the kind of founded that lab and has a very strong background in malting barley analysis. That's his background for his 20 years or so. So he's a very good resource. And if I don't know the background of the participants, but if any of them are farmers and are interested in growing barley, another good lab is out in Michigan, and Montana has a lab as well. So there's about 3 in the States that are good.
Yeah, that's really cool. Yeah, I just learned about Hartwick and thought it was really cool. They have a whole brewing and malting kind of lab going on there. And then let's see. How did you, I guess we kind of talked about this, but like what made you decide to start like the first malting company like in this area? And did you like already know other brewers that would be interested in joining, or did you just kind of just like go into malting?
So yeah, the first part of that question was a fun aha moment right at this desk in this spot back before Thanksgiving in 2004 or so. Or 14. Yeah, 10 years. What's the difference? So bless you. So I was thinking of starting a brewery. I have a lot of the equipment for a 5-barrel brewery, and so I was shopping for a mill, and I came across some malting equipment. I thought, well, that'd be neat. I could make my own malt. That'd be something to differentiate me from the other brewers and give people a reason to come see me. And because I was kind of worried at that point, Butler Brewworks didn't open, but they announced they're going to. Would Butler support 2 breweries? Who knows? There's like 18 in Pittsburgh already. That seemed like too many.
Here we are now.
Right. So I thought, well, one of the things I came across when searching for equipment was a malting piece of equipment. Yeah, I already said that. Sorry. Lost track. My apologies. So then I started searching for some Pennsylvania malt to experiment with to see if what the flavor profiles are like, so I could start dialing in recipes. And at that point, there wasn't any Pennsylvania malt, so I thought, well, there you go. I don't have to start a brewery. I can start a malt house, and then I can visit all the breweries and taste all their beer and not be, you know, married to one recipe, I guess. So that was how I got started, where the idea came from. And then as far as, yes, before I started, I contacted all the breweries that were in the Pittsburgh area and said, hey, I'm thinking of starting a malt house. Would you be interested in buying malt from me? And everyone said, hell yeah, we'd be interested. And so it seemed like that solidified that it was a good idea and I'd be able to sell malt. So that's how I started off down that path.
Cool, cool. And what was like the biggest difficulty in starting the malting business? Was it like finding a place like the school, or was it just like finding farmers who wanted to start working with you guys, or what was it?
Those are both big challenges. So we initially were going to have a smaller malt house in our backyard, and we're agriculture here, but getting through all the permitting process was very time consuming. And that's when we found the school for sale. So it was a lot quicker avenue to get to malting sooner. So we jumped on that. And as far as finding farms, a lot of farmers were hesitant to grow barley around here. So before I bought the school, we had to go as far as I want to say it's south of York, Windsor, PA, to find someone to grow for us. And the minimum acreage was 100 acres, so it was a rather large commitment on our part. Once we bought the school and had a little bit of publicity, then I started having farmers contact me. And so it was a bit of finding farmers who are good at farming too. So I think in 2016, we had 15 farmers in Butler County growing for us, and one of them made a crop. So of the other 15, no one else made suitable quality barley. That farmer's made a crop every single year, and tomorrow actually we'll be receiving his barley. And so from there, we grew out to farmers that are more full-time farmers, and they generally have they're on a schedule to get the applications done when it needs to be done, not just on the weekend. So that's kind of what's needed when you're growing something that is somewhat sensitive to your applications.
Yeah. And would you say that like farmers were hesitant to grow the barley because of like the fungus you mentioned with Dawn and everything, or they just like had tried it before and it didn't work?
It's a bit of both. So even though we were paying a premium for the barley, it just wasn't something they wanted to take on. And so it has to do with where the cash crops are. So corn and soybean, we're making money for them, and as was wheat. So there wasn't any reason to diverge from that path. So it's they just didn't want to take on the risk, I guess.
Well, it's the risk, and obviously it's way more labor intensive than a normal feed barley. It takes a little bit more care. So
you can just throw it out there and leave it in the field.
I think the other thing too is the infrastructure. So if someone was growing for us, we couldn't originally receive all that barley, so they had to have some storage or some way to handle it. So the PLCB board put out grants. So for all you beer drinkers and whiskey drinkers out there, thank you for helping build storage for the farmers here in Pennsylvania. Now we have a couple bins we could put barley in.
Yeah. Oh, that's so cool. So you guys now, with that grant, you were able to create like a place that you could store your grain.
Correct. We have 3 bins up now. So we had purchased the one, and then in 2018-19, we got a grant for the first drying bin, and then this past year, so we're finishing up our second one now in 2021.
That's great. Yeah, I know that's a huge issue, especially with like bugs and pests and things. It's just like, where do you keep it, and how do you know if it's going to be good by the time you sell it? And that becomes really tricky. We had Brian just popped off here, but he said, great presentation. Thank you. Just so you know. And then I think we have we have time for one more question. I guess, how did you hear about the grant with the PLCB? Was it because of like the Philly Grain and Malt Symposium? I know that they do that. Or was it through just another malter or brewer?
I think it was through a friend of ours. Christine may have tracked it down, or I can't remember.
Just Cool. Yeah. And then last but not least, do you guys have a favorite local beer that uses your malt or distiller?
Well, I'm after this going to buy a keg of the American wheat from Recon. That's I'm not supposed to say that we're buying kegs because they don't sell them. We know a guy.
Well, it's already on the webinar.
But that's very nice. Insurrection has I guess it's summertime, so wheat beers seem nice, but they have, I think that might have been a Hell Slogger. That they do some nice beers. 4 Points, I mean, they always make great beers down there, so that you can't go wrong. I wouldn't say I have a favorite. It just, I like them all. They're good beers. Mondays, if you haven't been down there, Sam does some good things in the South Hills. There's that loophole. If you're into gozas, that loophole number 5 is a very nice one. So it depends what you like.
Yeah, no, for sure, for sure. Well, I think Cassandra, we're good on time now, so I think we're gonna wrap up.
Thank you all so much, Oana and Brendan and Christina. Thank you so much for today's presentation and conversation. It was wonderful, really insightful. I know I learned a lot. So thank you for taking the time to join us today. And I did just put a survey, a feedback survey in the chat for our participants just to help us continue to grow and improve our programming and craft. But that's it for today, and we hope to see you all soon. Thanks so much.
Thank you.
For having us. Thank you.
Thank you. Bye.